video, we studied that sound needs a medium for propagation. That is, it requires some medium to travel from one place to another. But how does it really travel through the medium? What happens to the particles of the medium? Let us find out. We now know that sound is produced by vibration. When the object is vibrating, it sets the particles of the medium around into vibration. In the process, the nearest particles to the source gets displaced from their mean or equilibrium position. They start to collide with the particles adjacent.
Remember mean position, or we can say equilibrium position. I told you both words. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
So from the mean position or from the equilibrium position. For example, if you have been taken, now air there is no disturbance. So all the particles are with the equilibrium position, means equal distance. This is what is the particles which are present in that. Now, if there is a disturbance, then definitely either they will come closer, If they will come closer, we used to call it as a what? Compression or air fraction. Everybody, compression. If they will go far each other, we used to call it as a what?
Rarefaction.
Rarefaction. That is how the disturbance will create. So, that is what you all should remember that. All of you understand? Everybody, please respond, guys. Yes, so you can see now.
Yes, sir.
See that the particles from the main position, now they displaces because of pressure, high density. So now they are coming closer. So it is a what? Compression or air fraction? Compression. Now the energy is transferred from these particles to these particles. Then they will start moving and they will start displacing from the main position. So they will go and hit the next particles. You can
to them. The adjacent particles then also get displaced from them.
here. Now, when these particles will displace, so by the time you can see these particles having lot of space between them. So this is only what we used to call
Rarefaction.
rarefaction. Do you all understand? Everybody, please respond, guys. Girls, boys, everybody, Prudvi. Yes?
Yes, sir.
Yeah.
Yes, sir.
Now,
mean positions. They in turn do the same to their neighboring particles. This process continues in the medium till the sound reaches our ear. We see that we create some disturbance flowing through the medium. This is the way that sound.
have you checked it, everybody now? See that. Rarefaction followed by compression, rarefaction followed by compression, rarefaction followed by compression, rarefaction followed by compression. So until it will reach us to the source, it will be keep on following one compression followed by
travels through the medium.
one compression followed by rarefaction, compression followed by rarefaction. Now see, compression, rarefaction, compression, rarefaction, compression, rarefaction, compression, rarefaction. Do you understand, guys? Everybody? Clear? Yes? Everyone?
Yes.
So, the neighboring particles keep on disturbing until it will reach us to us. Suppose by the time energy over, for example, now there is a limit for everything. For you can notice it, the sound cannot travel to the longer distances. Suppose you can take, I am speaking now. My voice may audible to up to my neighboring house, but after the next it will not be. Means what? By the time the transferring energy is not sufficient to continue further. So there will be like some extent only my sound is audible. So that is what you can say. Means the energy what is producing by my sound having a capacity to travel up to that distance only. After that it cannot be. So that is how it will be. If you are in a range of that, you can hear me. Otherwise you cannot hear. Clear, everyone? All of you? Yes? And you remember, when the energy is transferring, the energy is not remains constant. It will be keep on reduces. When the time being, when it will travel a longer distance, that energy is not sufficient to disturb the particles next. So if you are in a before that range, the sound can reach us to your ear. Otherwise, you cannot hear it.
See that particles of the medium are not traveling from the source to the human ear.
They will never travel. Only what they will do, everybody. No particles will travel. What they will do? They will just get vibrate from their equilibrium positions. Do you all understand, everybody? So from their mean position, they will start doing the to and fro motion. That is what it is. They are not at all displacing from the source to the listener. Only they will neighboring particle, just they will transfer the energy. That is what you have to remember.
Here, it is the disturbance produced by a source which is traveling in the medium. The particles are merely oscillating from their mean positions. This disturbance created by the
Oscillating only, we are calling as a what? Vibration. That oscillation, to and fro motion, back and forth motion is only we used to call it as vibration. Is it clear, everybody? Do you understand, guys? Yes, please.
Yes, sir.
Yeah, that's what.
vibrating object in the medium is what we call a sound wave. But what does this disturbance look like? Let us study this with the help of a tuning fork. Here we take air as a medium of propagation.
See, that compression refraction produces in every side. Now, these prongs of a tuning fork, is it in disturbance or undisturbed? Everyone?
Undisturbed.
Yes. Mr. Darshan, always you keep it in mind. Join with only your number. Okay. So now, undisturbed now. So when I hit with the, you can see that. Yeah. So the sound needs some force to vibrate more distance. Yes, Kishore. Force, without force, you cannot. Your speaking means you are producing the force. Now I am hitting this tuning fork with a rubber hammer so that the surrounding air will completely disturbed by it. So that is how the propagation.
Here we have a tuning fork made up of steel. This shows the initial condition of the air particles of the medium when the tuning fork is in its original position, that is, when
This is call it as a what now? Now air particles all are in equal distance. This is only ways to call some position. What is the position? Anybody? Equilibrium position, or they are at their mean position. What is that? They are at their mean position.
tuning fork is not vibrating. When we strike its prong on a rubber band, we start hearing a sound.
See that the tuning forks, they are going outside and coming inside. Have you noticed it, everybody? Tuning fork is vibrating like to and from motion. Each prong will go outside and inside, outside and inside. Check it.
How does the sound travel
Yes or
through the
no, guys?
medium? The two prongs
Yes,
of tuning
yes.
fork are vibrating. Let us concentrate on motion of one of the prongs first. Say the one on the right. When it's away from its mean position, it pushes and compresses the air particles around it.
Now it is right side it is. Am I right or wrong? Exactly I discussed or not? Everybody. Now tuning fork is pushing right side. Pushing right side means definitely the particles which are closer to it will get disturbed. So that they will get compressed. So compression means they are producing the what? They are get compressed. Density is increasing. Pressure is increasing. So they are coming closer. So what they are creating? Compression or rarefaction? Compression. Now that energy will transfer to the next particles. By the time the tuning fork will go to the towards the left. So now these air particles having more space so that they will create a what? Rarefaction.
This creates a high pressure region, also called compression.
Compression. High density and high pressure. Anything.
Compression travels in the medium as a disturbance. Here the density is high.
Next, low density, normal density, not low density. This is what actually? This is what actually?
This
Normal density. Understanding, Amma? This is normal density. Compression is high density. Rarefaction is the low density. And the straight line, the graph, if I draws, there is a pen. I lost the pen. Yeah. The graph when we draws, even I have explained you people. So the graph when we draws, compression high density, rarefaction low density, and this is a what? This density is a what? Normal density. Okay, so please note that, and it's very, very important one.
the particles are very close to each other. When the prong comes towards its mean position, the pressure on the right decreases.
Now see that. Now the prong comes to left side. See that, so that more space is available. So what will happen? By the time the energy is transferred to the next set of particles, and these particles have a lot of space, so they will go for each other. So that is what we used to call as
And
rarefaction.
keeps on decreasing further as the prong continues its motion towards left. This creates a low pressure region.
Low pressure or low density. That is only we used to call it as a what? Everybody. Yes?
Rare fraction.
Rare fraction. That is what you have to remember. Clear, everybody? Hope you all understand, guys.
Yes, sir.
Yes? Any doubt, please let me know, ma. All of you?
Yes, sir.
Yeah. Make it.
Also called as rarefaction. We see that at this point,
And now this density is what? Lesser than normal density or more than the normal density?
Lesser than the
Lesser than normal density. That is only ways to call it as a what? Rare fraction.
Rare
What is to call? Rare fraction. So please remember that. All of you understand? Everybody?
Yes, sir.
Uh,
the compression in the form of disturbance has reached this region. This rarefaction also travels in the medium as a disturbance. Here the density of particles is less. That is, the particles are far away from each other. As it continues to vibrate, we get a series of these compressions and rarefactions. This continuous sequence of compressions and rarefactions is what we call sound waves. Yes, the sound waves travel in the form of compressions and rarefactions. Instead of the tuning fork, if we take any other source of sound, say the speaker, then the sound waves generated by this object will also travel in the form of compressions and rarefactions. Here is one interesting question. Is the sound wave a mechanical wave? Do you know what a mechanical wave is?
yesterday,
The mechanical
am I right or wrong? Sound wave is a mechanical wave or not, guys? We need medium or not?
Yes, sir.
Yes. So sound wave,
Yes,
what is
sir.
mechanical wave? Definitely material is needed for propagation. That is what mechanical wave. I taught you or not yesterday's class.
Yes, sir.
Yes. So now sound is a mechanical wave or not? A wave that requires some material. A wave which need a material medium for the propagation. So that it may be a transverse wave or maybe a longitudinal wave. Doesn't matter. So now you tell me. It is a what? Sound wave is a what wave?
wave is a wave that requires some material medium to travel. And as we know, a sound wave also requires some medium to travel. So yes, it is a mechanical wave. How do you define vacuum? Can sound travel through it?
Sound can travel through vacuum? Generally, I am saying sound cannot travel through vacuum. So that is what we used to say.
To find the answer to these questions, you have to wait for a
Understand, everybody? Sound cannot travel through the vacuum. Why? Sound definitely need medium for the propagation. That is what we will discuss in the next class. So that is only, everybody remember, sound needs a medium to travel. So that is what we'll discuss. And then we'll continue the characteristics of a sound wave in the coming class. So with this, I'll stop. I hope you all understand now. Today's class, two concepts we'll learn. One is production of sound and the second one is propagation of sound. Very, very important. So everybody go through that and once again read the entire text what you have. All the things up to here, page number, you have to read it and you have to make it. Okay. And then we'll continue. Sound needs medium or not? Definitely. Sound cannot be here without medium. So this experiment won't be in our classes. So 8th class only will get it. So then you will go through that. So till here, all of you read it and you can make it. Anything doubt you can ask me. After that, tomorrow we'll discuss what is sound needs a medium to travel and then what is the characteristics of sound we can make it. Okay, guys, everybody. No, Kishore having a doubt. Sir, a sound speaker in a maximum volume is a transversal or longitudinal? Always longitudinal. Understand, Kishore? The sound wave produced by a speakers, everything is a longitudinal waves. Okay, clear?
Yes, sir.
So that is what. Thank you, everybody. So with this, I'll stop and we'll continue from here. Everybody go through that and read up to here and we'll make tomorrow. Thank you.
Thank you.